Now we've heard about what's going on with our water supplies now, and we're going to start thinking about what's going to be coming down the road. This session is going to be moderated by Eric Wahlberg from Manomet.
Hey, good morning, everybody. Give folks just a minute. Folks in the back, can you come on up? Hello? Oh, well. Let's go. Okay, so I'm Eric Wahlberg, Senior Program Leader for Climate Services with Manomet. Just a quick introduction for our panel here. To my immediate right, we have Sarah Burns. She's a water resource scientist with the Nature Conservancy. Next up, Bill Napolitano. He's Environmental Program Director with SERPED. And Heidi Rishi, she's Assistant Director for Advocacy at Mass Audubon. So we've got a great group, and we're going to be focusing today on future of water. As far as goals for the session are concerned, we're really going to be focused today on two intersecting stressors, one of them being climate change, and the second one being urbanization going forward. So we're going to think about how these two combining stressors are going to impact both water resources and associated ecosystems. We really want to spark some creative problem solving on this. I think, as you know, our final session today is going to be facilitated discussion. So I think it's really an opportunity to roll up our sleeves and think about these issues. And I'm going to offer you just a short example, and this really ties back to the situation that was described and set up in the USGS presentation at the very beginning. I've been working with our group here through the MVP process with a lot of communities now in eastern Massachusetts. And one of the features that really strikes me about that process is that oftentimes you get into these discussions, and we've gotten pretty good representation in each locality from a pretty good cross-section of folks. Oftentimes, people characterize natural systems as really being more of the problem than the solution. And in the example that was given in the USGS talk about this notion of green infrastructure, trying to encourage local infiltration of stormwater, and the counterbalance that you get there with the possibility of rising water tables with climate change. And so it really sets up this perceived tension between green infrastructure and gray infrastructure. So the challenge I'd like to put out to the group today to think about and to work through in our afternoon session is how do we get smarter about thinking about the changes that are underway? How do we tie water management, management to linked ecosystems to a package where we're addressing the concerns that the localities are surfacing through the MVP process and hopefully describe some win-win solutions. Okay, as far as our presentation structure today, I'm going to start it off with sort of an update on climate. I know that this audience is really familiar with climate change issues. Think of this as being an update if you haven't had a chance, for instance, to look at the latest version of the National Climate Assessment. I'm going to kind of bring you up to speed on what the latest findings are there. Next up, Heidi's going to talk us through development trends and projections. She's done a lot of work with the Losing Ground series of reports at Mass Audubon, and she's going to walk us through that and some scenario projections for future development in New England. Thirdly, Sarah's going to talk us through combined impacts of climate change and future development on water resources. And then finally, Bill's going to bring us home with some discussion of the MVP process that we've been involved in, characterization of that as a vehicle for some of the issues that I've just teed up, and also bring in some other funding opportunities as well. Okay, well, I'm going to start off with an animation, and just to tee this one up, this is global temperature anomaly, or departure from normal, if you will. It runs for a period of approximately 120 years. The blue colors are a -2 degrees Celsius departure. The darkest reds are a +2 degree. You'll see the date at the bottom of the screen so you can kind of keep track as I run the animation. Okay, and that brings us up through 2018. So I think this is just, to me, a really striking way to think about how the planet's changing. Really underscores the fact that just within the last 30 years or so, the rate of change has really accelerated. So I think it just really underscores the situation that we're in. Okay, so a series of slides. This is going to be both precip and temp change. Most of these images are from the latest version of the National Climate Assessment. This first one is observed change in precipitation. It's in percent. The darkest greens are a 15% increase. The darkest browns are a 15% decrease. So this gives you a good spatial distribution of how things are changing across the lower 48. Obviously, in our part of the world, we're seeing a really significant increase in annual precipitation, with some of the region seeing 15%, most of the region at least 10% increase. Now this slide is all about changing heavy precipitation, and I think for us in New England, this is probably actually the more important driver, if you will. There are 4 different panels here, so I'll walk you through each one. Now again, this is all in percent change. You can see the scale down at the bottom with the darker blues at the highest end. Upper left panel is 5-year maximum daily precipitation. This is roughly the last 100 years. For our part of the world, we've seen a 27% increase. Next up, on the upper right, 99th percentile precipitation. This is the increase in really heavy downpours. If you're thinking that, okay, over time it seems like when we get precipitation, oftentimes it's just in the bucket full now. Well, that's what this 99th percentile is about. Here we've got, over the last 50 years, roughly a 55% increase. Next up, lower left, number of 5-year 2-day events. Looking at a 100-year period of record, a 74% increase for our part of the world. And then if you look at the last 50 years for the same category, we're up to over a 90% increase. So I think that if you're really starting to think about both water system impacts and associated ecosystem impacts, it's not just the changing average that's important here, it really is the changing extremes. And I think that probably for us, this is actually the more important driver for both areas of concern. Okay, so next up, now we're switching over to model projections of the future. This is out through 2100, broken out seasonally, winter, spring, summer, fall. In winter and spring, the red dots indicate where we've got statistically significant increases projected. In all cases, across all seasons, we've got increases projected for our part of the world. In summer and fall, those are not necessarily statistically significant changes. They fall within natural fluctuation. But I think it is important to notice the seasonal differences. So the more significant increases in annual precipitation projected to come in winter and spring. Okay, so this slide, I think, really starts to tie together the 2 variables that we've been talking about. And if you will, there's sort of a tug of war taking place between the changes in temperature that we've got going on and the changes in precipitation. If you looked at the changes in precipitation, the trends and the projections, it's easy to believe that we're just going to have incredibly plentiful water resources going forward. But on the other hand, with the rising temperatures, we've got a longer growing season, we've got increased evaporation rates, increased evapotranspiration rates, and so this set of maps shows you how soil moisture is projected to change, again through 2100, the same sort of setup we saw before with the different seasonal panels. So you might ask yourself, this is a little bit of a head scratcher, how could this be with what's going on with precipitation, that we could be heading into a drier soil moisture situation? And again, it's really all about that tension, that tug of war. And so it's something that we're really going to have to pay attention to going forward. Now, I think it's very likely that we're going to see situations increasingly where we've either got too much water during part of the year or too little in another part of the year. And most likely what we're going to see is that in the winter months on into the spring, those are the situations where we're likely to have more flooding and excess of water. In the summertime, with the changes in the growing season that I just spoke to, more impactful drought. As the temperatures go up, it's likely to see that some of the problems that we've got with water shortage are going to be exacerbated. And of course, all that's going to carry over into ecosystem impacts as well. Okay, so switching gears, and we're going to talk just a little bit about sea level rise. This is measured data going back 120 years. And the take-home message here is that the rate of change in sea level rise is increasing. So if we look going back to the earliest part of the period of record, 0.8 millimeters per year, progressing to 1.9 millimeters per year, and then finally up to 3.2 millimeters per year. And so not only is sea level going up, the rate at which it's going up is accelerating. Now, projections going forward have everything to do with greenhouse gas emissions rates. Currently, global greenhouse gas emissions rates are ramping up again. If that trend continues, then there's every reason to expect that this rate of change in sea level rise will continue to accelerate as well. Okay, so how does this play out? This is from a recent study for Boston, but the take-home messages here really carry over for all of New England. There are three different emission scenarios here. Blue, a very aggressive drawdown of greenhouse gas emissions. Green, sort of a medium emissions, and red, higher emissions going forward, and then 2030, 2050, 2070, and 2100. Want to focus your attention on 2100 because that's really where things get interesting and somewhat confounding from the perspective of environmental planners. That's where you start to get a real division between the different emission scenarios, and look how the uncertainty is really starting to increase, particularly for the higher emissions scenario. We've got the possibility of anything in the range of 3 feet to perhaps at the upper end of the scale, 9 feet of sea level rise. That's obviously a huge range to take into account when planning for this. And we're going to talk right at the end of my presentation a little bit about the role of uncertainty in these model projections. So. Okay, so how does this play out on the ground? This is a study, it's a few years old now, but I think it's useful in that it looks at changing probability of storm surge flooding associated with sea level rise. This is the current situation. The way the scale reads, these yellow, pink colors are at the low probability end of the scale. The blue and purple are at the high end of the scale. So the take home here is that it's a relatively small footprint area that's vulnerable to flooding, and it's a relatively low probability. Okay, this is moving forward to 2070. This assumes approximately 3 feet of sea level rise, and so two important changes. The footprint has increased fairly significantly, and also the probability is ramped way up. I mean, the areas that are most vulnerable closest to the harbor are now at close to 100% likelihood of flooding with that sea level rise. Now, obviously a Boston-specific study, but you can really take this same pattern and apply it to almost any low-lying stretch of the coast here in New England. Now, New England's not nearly as vulnerable to sea level rise as areas further south because of the topographic change that we've got, but in the low-lying areas, this is very much going to be the situation. Okay, so to close out my section of the talk, a few key concepts to kind of wrap things up here. I've already spoken to this a little bit, but it's really important to think both about changing averages and changing extremes. We had a pretty detailed discussion of the changing extremes for precipitation, of very similar things happening with temperature. If you think of, sort of a normal distribution of temperature, and if you take that bell curve and shift it to the right, think about what happens to the tails of that distribution. We're losing the extreme cold, if you will, but we're picking up a whole new category of extreme high temperatures. And so I think ultimately that's going to end up being the really important driver for water resources and associated ecosystems. I think that probably over the next 20, 30, 40 years, it's going to be those changing extremes that really cause shifts in the resources. Going out further, certainly the changing averages are going to create a situation where a lot of ecosystems are sort of driven out of their comfort zone, if you will, but really pay attention to those changing extremes. Want to focus just a little bit on how we deal with uncertainty in model projections. I think everybody's probably heard the saying, all models are wrong, some models are useful. That certainly applies to climate models. And there are a number of reasons why we can't really pin these things down. The first is we just don't know what greenhouse gas emissions rates are going to be going forward. As I said, a few years back, we had reached a point where globally the emissions had really plateaued, and there was a lot of thought that we had been successful in decoupling economic growth from emissions rates, and that was really a hopeful sign. Well, unfortunately, now we've pivoted back into a situation coming out of the global recession where globally the emissions rates are going up. So the decoupling we'd hoped for really hadn't happened. So that's the largest source of unknown, if you will, in the model projections. But there are also some other factors to consider. There are feedback loops. These loops can be positive, meaning that they enhance warming. An example of that is the loss of sea ice in the Arctic Ocean. It opens up large expanses of darker ocean water that absorbs more heat from the sun, so it accelerates warming. On an example of a negative feedback loop, as we get regions that historically had snow cover in the wintertime, if that snow cover goes away, we can get into an opposite situation. We've also got the notion of intersecting stressors. And I think that from an ecosystem perspective, this is really an important consideration. If you look at what's happened to forests out in the western U.S., I think it's really a graphic example of this. If you're familiar with a lot of the forest mortality, it's a situation where we had a naturally occurring cyclical drought. The higher temperatures created what's referred to in the scientific literature as hot drought, or a more impactful version of drought, if you will. The warming temperatures also enabled a range expansion by the mountain pine beetle, so you had a pest that was affecting these stressed trees and really ramped up forest mortality. So I think it's those sorts of intersecting stressors that we really have to watch out for in thinking about ecosystem management here in New England. And then a final example of uncertainty in the models is the notion of tipping points, or changes that can happen that really aren't well forecast by the models. Just one example there's been a lot of work looking at ocean transport currents, a lot of evidence from paleoclimate work that big shifts in our climate were driven by very significant changes in those transport systems. So if we reach a point where we get one of those types of events, a lot of the model projections are not likely to be correct. So, all right, and then one closing thought before I pass it over to Heidi. Given these uncertainties, I don't want you to feel like you're left in a quandary about how you deal with this. And in my work at Manomet, one of the things that I've really come to focus on is thinking about what the trend information is, what are the measured trends in water resources and environmental response, et cetera, and really starting to take that into account in conjunction with enhanced monitoring of what's happening. Now, I know monitoring is not a really glamorous thing. It's oftentimes very hard to get funding to cover monitoring projects, but I think we can use the models to bracket what the future's likely to be, but it's this combination of looking at the measured record and doing some enhanced monitoring that I think is really going to tell the tale. All right, so with that, I'm going to pass it over to Heidi.
Thanks, Eric. So that was a really great overview of where we are with current thinking on climate science and where things are headed. I'm going to now bring in a little bit more information about the intersection with land use and how those two things, climate change and land use together, affect our water resources. And I hope to leave you all with some messages of hope that there are actions that we can take at the local and regional and state level that can help us both reduce our emissions, climate mitigation, but also adapt to changes that are already underway while still having other multiple benefits for our communities. So there are positive things we should do, and we shouldn't feel like this is an unresolvable problem. So a lot of the resources and information that I'm going to talk about is available through Mass Audubon's Shaping the Future of Your Community program, which I oversee. We created this program in 2009 to assist communities in charting a more sustainable pattern of development as well as targeted land conservation. How many of you are familiar with our Losing Ground reports? Good, maybe half the people in the room. So about every 5 years, Mass Audubon does a report on land use, and I'll talk about that a little bit more as well. So again, just to overview land use and water, the future in a changing climate. I'm going to also show you some future scenarios that Harvard Forest has developed and talk a little bit about how that could interact with sprawl, imperviousness, water resources, and then some regional applications. So this Harvard Forest report and modeling tool, it's called the New England Landscape Futures Explorer, and I encourage you to check it out online. It's a really nifty, easy to use web browser kind of tool that has a ton of resources, and you can play around with it and zoom in to your local sub-watershed, your community, and do a lot of analysis, not just mapping, but also get a lot of data. So this is through something called S3RCN, which is Scenarios, Services, and Society Research Coordination Network that Harvard Forest has put together. And they got a lot of people together from all across New England and asked some questions. How might our landscape change in the next 50 years? If you were standing on the top of a mountain looking out across the region, what would it look like 50 years from now? What are the possible consequences of that? And what action can we take to sustain the functions and values of the natural lands that they're providing us? So these are the scenarios that they developed, and I'm just going to let them run here. I talk about them a little bit. I'm not going to go into a huge amount of detail except to say, so there are 5 different scenarios. The one in the middle is just mapping out recent trends in land development and going out into the future. These all go out to 2060 in 10-year time increments. The other ones are on different scales of either local planning and control, so smart growth and sustainable development and targeted land conservation. And then the other axis is kind of globalism and how much we're focused on kind of local resources and communities versus like the growing global scenario on the lower right. There's a kind of a combination of uncontrolled, unmanaged development along with a huge influx of migrants to this region. Many of them may be climate refugees. So it's, you know, they're not saying that any... What are the colors? Okay, the colors. The dark green is protected forest land, light green is unprotected forest land, red is urbanized development, blue is water. Yeah. So they're not saying that any one of these is going to be the future that we will actually see, but it's giving you some framework for thinking. There's a lot of information, as I said, on their website, again, New England Landscape Futures, that explains how this was put together and how you can use the information. So now back to Losing Ground and what's happening here in Massachusetts. We do this report every 5 years. We're working on the next edition now. The last one came out in 2014. We'll be issuing a new report this fall. And we have seen some improvement over the years in sort of the amount of acreage, the rate of loss, and also an increase in the rate of conservation. It'll be interesting to see whether that continues or not. I rather suspect not, because the last edition was done during the depths of the Great Recession. So when we were talking about 13 acres per day being developed, you know, it's likely going to be higher than that now. And also, the state has not been investing quite as much in land conservation. They're still doing a lot, but not as much as they had been under the previous administration. Oh, and just to also point out, so that the areas in reds and orange, that's what we call the sprawl frontier, those are the most rapidly developing parts of the state. And we've seen, you know, sort of an ongoing trend, the 495 belt and beyond, and then even out to the southern Pioneer Valley. And a lot of that still is large lot housing development that does not meet the housing needs that we have for the average resident. And it eats up a lot of land. So in terms of hopefulness and where we are and where we're going, on the left here we have a graphic of how much land we've developed, how much has been conserved, and how much remains. So about 22% of the state as of 2013 was developed, about 25% was permanently protected, and just a little bit more than half was undeveloped and unprotected. So that gives a lot of opportunity for both meeting our development and economic needs as well as targeted conservation, because we still have half the land in the state that's up for grabs. And then out of that half that's left, in the lower right here, about 54% of that is high priority for conservation. So there's an opportunity, again, to do both, but we just need to be targeted in the way we do it. As Eric said, we're already seeing a lot of changes. This just quickly summarizes kind of from a more local perspective here in New England, what has already happened in the last century, decades, and we're going to be seeing more of it. So how do these things intersect? With climate change, we have increased precipitation that increases with these big storms, stormwater and flooding issues. It also increases water quality issues because you get more rapid runoff from developed areas as well as more erosion and infrastructure damage. Increased temperature has impacts both on human health and on natural ecosystems such as fisheries and other aquatic life. And then we add to that the sprawl. And what do we do with sprawl? We make a lot of paved hard surfaces, which make the water run off even faster and not infiltrate as much. And since the storms are coming in these faster batches, they're already losing recharge even without the sprawl. And this just makes it worse. And then, of course, during the summers, you get a storm and all that heated pavement, that adds more heat stress to the waterways as well. So these things multiply. But if we value our natural landscape that still remains, and we recognize at the local level with our municipal officials who are doing planning that the natural landscape is providing free services for us, again, the earlier speaker mentioned economic arguments, and we're working on pulling some information from the literature and more numbers around this, but just sort of qualitatively, you know, our forests are sequestering carbon, about 86 tons per acre is held on the average acre of forest in Massachusetts. Clean water, flood protection, habitat, tourism, recreation, and just general health, property values, quality of life, all the things we love living in this beautiful part of the country. And here's where we start getting into what are our options and how can we get where we need to be economically while still minimizing these impacts on our water resources. So this is from a previous report that Harvard Forest did just for Massachusetts before they did the region-wide scenarios. It was called Changes to the Land. And I don't expect you to be able to read all the details here. Just to get the general idea, these are 3 maps of recent trends projected out to 2060. On the left is impervious cover, in the center is water runoff rates, and on the right is phosphorus pollution. Darker colors are worse situation, more runoff, more pollution. Bigger dots are worse. So that's the recent trend. But if we were to value our forests as infrastructure and do our development differently, you can see that the brighter colors are a little bit less, the dots are a little bit smaller. And these two scenarios have essentially the same amount of development, the same number of new housing units, all that. It's about doing it more compactly and using low impact development techniques, which I'm going to talk about a little bit more. So it's not necessarily development or conservation. We can do both if we do it smart. Another example from that same report is sort of the opportunistic growth. This is similar to the growing global under the new scenarios, kind of just unconstrained development, no, local planning and zoning kind of go out the window and let people develop willy-nilly wherever they want, and compare that to the valuing our forests as natural infrastructure. And here you really begin to see dramatic differences with the much darker colors and bigger dots. So the decisions that communities make on what they're doing with their zoning and their subdivision regulations is very arcane and boring, hard to sift through, but it's really important because each of those decisions that are made on specific developments add up over time. So how might we apply these scenarios in thinking about the future in relation to water? So this is a depiction of sprawl under the connected community scenario on the left, which is the one with the most planning and the most appreciation for our natural local landscape, and the one on the right, which is the growing global, kind of out of control example. And here the colors are, red is that you're somewhat urbanized already, but you're sprawling like crazy nonetheless. And sprawl is defined as 7.5 acres of development per square mile per time step. The gray is already developed and not sprawling, and you'll see on the right that that area expands because at a certain point you're sort of built out, so you're no longer sprawling. And then the yellow is the non-urbanized areas, and here urban and non-urban are defined as kind of the 50% developed threshold. And the point is that we could have two very dramatically different futures here. And which one do we want? And if we want the one on the left, how can we get there? This is another way of, again, viewing the same data, but looking through the lens of impervious surfaces. So there's some literature out there that says at about 7% imperviousness in a watershed, you begin to lose some of the fish in your natural fish assemblages. And so that's the pink color. And then between, so that's between 7 and 12%. At 12%, you really typically begin to have significant water quality impairments and are not meeting water quality standards. So again, very dramatically different potential futures and choices. I just want to quickly mention how we have applied these scenarios in a project we're doing under an EPA grant, the Southern New England Estuary Program, in partnership with the University of Rhode Island and the Natural Capital Project at Stanford. So we took data on the Narragansett Bay watershed, which you think Narragansett Bay, you think about Rhode Island, right? But 60% of the Narragansett Bay watershed is actually in Massachusetts. The Blackstone watershed on the left and the Taunton watershed on the right are the two largest watersheds contributing to the bay, primarily in Massachusetts. And they're also two of the most rapidly developing watersheds, but they have a lot of undeveloped, unprotected land available. So we wanted to look at, well, what would this mean under the Harvard Forest Land Use Futures? The Narragansett Bay Estuary Program just came out in 2017 with a big technical report about the state of the bay and a whole slew of different indicators. But one of the most significant findings was that between 2001 and 2011, the amount of nutrient pollution coming into the bay had been cut in half. So a very significant improvement is primarily due to upgrades in wastewater treatment plants. So, you know, we wanted to look at the future scenarios and how that might play out. URI is also doing a straight economic report, which I'm not going to really go into here, except to say that tourism is by far the largest economic sector in this particular watershed. So under the Harvard Forest scenarios, the Narragansett Bay watershed, which is now about 50% forested today, under the Connected Communities scenario, it would remain 46% forested, whereas under Growing Global, it would be about 22%. And the modeling also did some analysis of water quality. There's some difficulty in doing this analysis because there's not good information available on impervious surfaces and stormwater systems and how that's contributing non-point source pollution. But they did find under the Growing Global scenario that unless there was major investments in new wastewater treatment systems, there would be very significant bacterial impairments. So knowing that in Massachusetts we already have a $40 billion backlog in water, wastewater, and stormwater infrastructure improvements, you know, what we have for future land use really plays into that as well. And then the last example I have is from the Resilient Taunton Watershed Network, which my co-speakers here are all parts of. This is a group of about 19 different organizations and agencies that are working in the Taunton Watershed. Eric and his staff at Manomet have developed this green infrastructure network map, which took the sort of biomap and resilient lands that are important ecologically, as well as lands that are floodplains or close to waterways, overlaid those, mashed them together, and then cut out the already protected lands and created this green infrastructure map, which is the 30% of the watershed that is undeveloped, unprotected, and of highest conservation value. So we use this in talking with communities and the MVP program and other planning opportunities. And what I'm really interested in doing next, if we can, would be to apply the Harvard future scenarios to that and do some what ifs and work with communities to say, so this big green blob here that's an important part of our green infrastructure network, how would that play out under these different scenarios? And what are your land use rules and what's likely to really happen? We also have another mapping tool, the Mapper tool that Mass Audubon has developed. It's on our website. You can also get to it through the shaping program. And this you can use as kind of a more localized scale to look at specific parcels and rank them for protection. And finally, I'm just going to wrap up with a little bit about low-impact development. Sarah's going to get into much more detail and examples of how these kinds of concepts can be applied, real-life sort of project examples. I was doing kind of 10,000-foot overview thought process examples. So low-impact development involves working with nature to manage stormwater close to its source and treating stormwater as a resource instead of a waste product. And I think Sarah's going to go into this a little bit more too, so I won't say a lot about it. But we have a bylaw review tool to assist communities with reviewing their rules and regulations. We also have fact sheets. There's a lot that can be done just by updating your regulations. And there are many grants available now, including through the MVP program. And Bill will tell you more about grants, so I won't go into detail on that. So thank you.
Hello, everybody. Okay, so I'm going to talk through some examples of how climate change and development kind of work together to affect our water resources. I'm going to talk about this sort of through the lens of natural hazards. This kind of tees up what Bill's going to talk about the MVP program. And as we saw from Eric's slides, we're seeing changes in our precipitation cycle, and that comes up a lot in the Municipal Vulnerability Preparedness Program. I'm also going to talk a little bit about some example solutions. And I just wanted to do a quick check-in on definitions. How many of you have heard of nature-based solutions? Okay, so that's more than half the room. This is a definition that comes out of the state's Climate Adaptation and Hazard Mitigation Plan. This is an effort that the state undertook wrapping up just this past October. It's the first combined climate change and hazard mitigation plan, I think, in the country. And they go into great detail about how climate change and hazards are going to interact. And I'm not going to touch on that too much, but this definition just says that nature-based solutions are projects that are developed to design solutions using nature or natural processes to protect public health and clean water, to increase natural hazard resilience, and to sequester carbon. Integrating nature-based solutions into local planning and design projects can produce long-term solutions that benefit both human and natural systems. And I think that last sentence is kind of part of the reason that the state's been focusing on this, and it's the same reason I think that we focus on this. You get multiple benefits for nature-based solutions a lot of the time. So you think about your primary goal, which could be hazard reduction, but then maybe you're also getting a tourism benefit, habitat services, protecting an ecosystem. So you get more bang for your buck with these solutions. And then finally, this broad definition includes work considering existing ecosystems and also green stormwater infrastructure or low impact development. So for an example of existing ecosystems, here we have a riparian zone. If you're managing or restoring or protecting a riparian zone, you're providing that is a nature-based solutions project. You can slow runoff, you can protect water temperature and water quality, you can provide habitat, and you can get some flood reduction services from that. So that's an example of an existing ecosystem solution. I talked about natural hazards a little bit on the first slide. This is a little wonky, but I feel like it's helpful, at least for me, to be reminded of this. Natural hazards are sort of the impact that we experience in storm events. So I think of it like if you were in a fight with someone and they punched you, the punch is the hazard. Whatever they're punching, if it's your arm, that's the asset that's being impacted. And that can actually be kind of tricky to tease apart when you're trying to think about these things. But as Eric talked about a little bit again, we're seeing changes in our hazard cycle because of the climate change effects. And I'm not going to go too much into the why of this because Eric did a good job of laying out the details, but basically climate change is impacting us by trapping gases and therefore heat and energy in our atmosphere. So all that heat and energy is providing more fuel and energy for storms and other weather events. So that really changes and intensifies our natural hazards. So I'm going to walk through a couple of examples. We heard a lot this morning about the sort of human demand on our groundwater and surface water supplies, which is excellent to know about, not that it happens. And Eric talked about this a little bit, but so we're seeing, because of climate change, different seasonal water availability. So we're getting a lot of our rain events as rain rather than snow, first of all, and in big gulps in the spring and in the fall. So that's leaving us with warmer springs, wetter springs, and then the stretches of dry periods in the summer are also increasing, and the temperatures are increasing. So what that means is we're getting a lot of water all at once, and then over the course of the growing season, there's not as much coming. So even though we might have an annual average that's pretty consistent with what we have experienced in the past, we might still enter into drought conditions. So as Heidi talked about development patterns, this is just one more illustration of just the impacts of impervious cover on groundwater recharge. In this top picture, you see when you get a rain event in a highly developed area, maybe as little as 10% of that precipitation makes it back into the groundwater. In a less developed or more natural area, you can see much higher percentages of that. So combined with the climate change impacts I just talked about longer, drier periods, and then increasing development, you can start to imagine that less and less water is getting back into our water tables. So this is the Canoe River Aquifer. This is in the Taunton River watershed in southeastern Massachusetts. This was the drought of 2016. These are both pictures of what should be the riverbed. This is a water supply area for 3 communities. And 2016 was a bad drought. This was not the drought of record in Massachusetts. So these are the kinds of impacts that we're already seeing and that we really need to think ahead to plan for. So this solution is not directly in that same system that I just showed you, but this is a project, a low-impact development project at Bridgewater State University. So in the pictures on the top left, you can see this parking lot area. The picture on the left is before the project. That parking lot flooded quite frequently. There's videos actually online of students running through like knee-deep water to get between the buildings to go to class. So thinking about both water quality and water quantity, the college worked with Horsley Witten, I think, to design a new parking lot. So this image, that aerial image on the right, is the parking lot with this new layout. They actually got, I think, about 50 more parking spaces by doing this reconfiguration. And as the cars line up nose to nose, instead of just having curbing, they built these little bioswales or infiltration basins. So we have vegetation in there to slow and use the water. And in rain events that are greater than what the vegetation can handle, there's a little outflow or overflow basin that pipes the water into these underground chambers. And those underground chambers are open on the bottom. So if the parking lot gets more water than the bioswales can just handle, it's pumped into these chambers and it can just wait there. And when the rain event passes, it can slowly exit through the bottom of those chambers and recharge. So they experience less flood events and they're encouraging recharge, and they got more parking spaces. So the next example that I want to talk about a little bit is the other side of this coin, right, is more precipitation. Eric hit on this already, but I like this slide specifically because it kind of talks about the variability that we see year over year, even though we see our trends increasing. The gray dots are the annual precipitation averages, and you can see they're kind of, they're up and down. And then the blue line is the 9-year average between any 9 of those given gray dots. And even that is kind of up and down. But that blue line through the middle is the trend, and that's the climate trend. And I bring that up just to say that even way out on the, the far side of that climate trend, which is 2015, because this is observed, not projected, we still can get a drought. And that'll be true going into the future. Our trend is increasing, but the variability year to year will probably be the same, if not even more drastic. So I showed this slide already, but I want to keep coming back to this as a simple graphic about the challenges of impervious cover. So again, on this top slide, we're still getting not very much infiltration back into the groundwater, but what I want to think about now is these bigger arrows. So when the water doesn't go back into the water table, what it does is it runs overland, as you can call it stormwater flooding or stormwater pollution. And I think sometimes I don't always think of this, but the National Flood Insurance Program has estimated that about 25% of their claims actually come from floods that are generated from development. So even stormwater flooding can have an impact on the hazard experience of flooding. Another thing that stormwater runoff can really contribute to is something called the urban stream syndrome. So if you look at the picture on your top left, that's sort of a natural area with a, you have your upland area, you have your riparian zone and your floodplain, and then you have your stream channel. And there's slope in there, but it's fairly gradual and it's tiered. But the river in a base flow is pretty well connected to its floodplain or close enough to its floodplain. And that's a fairly stable system. Like rivers move a little bit and they move sediment, but that system can handle some rain events and probably not be too impacted. The picture below on your bottom left is an urban stream channel. So what happens when we get that excess stormwater runoff is that it goes either just over the pavement or through our storm sewer systems, and it's discharged all at the same time to surface water. And John showed a hydrograph, I don't know if you guys remember that had that big peak for places with impervious cover compared to natural cover. And one of the consequences of that is that all that water can scour out the river channels. And so it's moving those sediments, it's destabilizing the banks. There's pictures of homes in Vermont where there's more topography with houses that were not riverfront houses that after one storm event are like hanging over the banks. So then I just have some pictures of that. This gives you our flashy flood events. That's a washed out road. I actually was in Vermont and I drove up that road and then it rained for 3 hours and then the road was gone. So I stayed in Vermont a couple extra days. Another sort of consequence of this type of stormwater driven flood cycles is that a lot of nutrients also get swept up as the water moves over land and get remobilized as that sediment gets moved away, and that's when we start to see nuisance algal blooms. So that picture down there is not a green grass pathway, that's a river with a nuisance, or a stream with an algal bloom. So this is an example where we have, you get this, so the hazard that this sort of impacts is inland flooding. These are both pictures from 2010 from the Taunton River watershed. There were big floods there then. So then a potential example solution, this one actually, that picture of flooding matches that picture of flooding solution, which is nice. So this is in Norton, Massachusetts. This road flooded pretty regularly, and right on the other side of this road, out of the frame, was a wetland area, and then the 3 Mile River, which is an area of critical environmental concern. And the flood events coming down this road really swept a lot of sediment into those wetlands, impairing them, and then was degrading the stream. So the Nature Conservancy worked with the Department of Ecological Protection to get a Section 319 grant, which is about stormwater management. And we worked with the town and a local land trust to build a bioswale right off the road. So, like, it's right here in this picture. And this bioswale has some inlet channels, and it has a rock check dam, and then it has a big infiltration basin. And there's vegetation in there now, but I don't have a picture of that. But this was built in the fall, not this fall, but last fall. And even without any vegetation in it, this held up to all 3 of the March nor'easters that we experienced. And that road didn't flood to the same extent during those events. So that's an example of a local solution. Okay, the next example I want to talk about is water quality. This is a fairly simplistic graphic, I think, but I like it because it starts to just tie together all of the different stressors, like what Eric was talking about. So this is an example that focuses on water quality impacts based on nutrient pollution. So you can see from these different land use types sort of around the edge of this estuary that urban runoff, ag and livestock runoff, and residential runoff, both through overland flow and in places where they're septic through groundwater flow, can contribute nutrients to not just our estuaries, but any of our surface water bodies. And when we have too many nutrients, we get those algal blooms, like that stream picture I showed you. And those algal blooms can really shade out any of the sort of native natural grass beds that might have grown there originally. It makes the water murky. It can be gross. In the case of freshwater, and sometimes in the estuary system, some of the algae can have toxic byproducts, so you need to be careful about that. And then when the algae dies, they fall down and they decompose at the bottom of the water. And especially when there's higher temperatures, that can cause that lower level of the water to run out of oxygen. And that's when we see fish kills. So that's one big cycle of nutrient pollution. So then when you start to think about the combined impacts of development and climate change, you can see that you get these sort of positive feedback loops that Eric was talking about. So a strong storm is going to give you more runoff from all of those land use types, which will result in more nutrients in the water body. Greater impervious cover kind of has the same effect. So in the stronger storms, there's more impervious cover, which means it's easier for that water to just flow over the land. And then with climate change, we're expecting to see increased temperatures. So water's ability to hold on to oxygen decreases when the temperature goes up. So if you have a nutrient-stressed system that's hotter than it used to be, you're more likely to see those dissolved oxygen levels drop. So that's one big kind of gnarly feedback loop. And the impacts of water pollution, I talked about this a little bit, but in both fresh and coastal waters, you can lose habitats, you can see property value decline, you can see the ecosystem completely shift, which is actually another example of something that Eric talked about, where, especially in this coastal example, you have seagrass over here, and then if you get too much nutrients and too much algae in the water column, that seagrass is going to die. And so you're in a new ecosystem type. So that's an example of a threshold change. And then in freshwater, you can also have impacts to your drinking water supply, both through these nuisance algal blooms and in areas with really dense septic systems, you can start to see accumulation of nitrogen that's not safe for people as well. Okay, so example solution for this one. As Heidi mentioned, the Mass Audubon's created a tool that we just call a bylaw review. And the cool thing about the bylaw review tool is that it helps you work systematically through your zoning, your bylaws, your ordinances. And before you do it, you can sit down and say to yourself, man, I have a nutrient pollution problem and a stormwater problem. So I want to make sure that all of these regs allow me to build green stormwater infrastructure to help deal with the problems at the watershed scale. And you can even develop bylaws to mandate appropriate fertilizer use and to start thinking about water restrictions, and just really try to think about your water resource as one thing and let your bylaws work for you in that. This is just one example. This is Westford, Massachusetts. The big takeaway from this case study is that one of the ways that you can change your bylaws is to make cluster development by right and not require a special permit to do it. Westford made that change, I think, in 1978. And just through having this subdivision requirement, the developers ended up purchasing and not developing and not cutting down trees on 17 acres of land, which preserves local habitat and water resources, and they created 13 miles of hiking trails and public recreation. So this saved the town a lot of money, preserved a cool character in town, and it saved a lot of ecosystem connectivity. So the bylaw review is pretty cool. This is my last slide before I kick it over to Bill. This one kind of, it doesn't, well, anyway, so nature-based solutions, they're an important tool. The state's really prioritizing them, both in the MVP program and in the state's emergency management pre-hazard mitigation grants also prioritize nature-based solutions. So if you're thinking and working with a town who might be in the middle of any kind of planning process, sticking the nature-based solutions opportunities into these various plans can really open the door for different kinds of funding and grant applications and can help move these solutions along. So with that, I'm going to turn it over to Bill. Yeah.
You know, I started planning about 33 years ago, and when I started, I didn't have to do this. Someday I knew I would have to do this, because, the world has been revealed to me. Yeah, this is the other thing. Podiums, I usually, and my colleagues can attest to this, I started out my career teaching. So I'm usually a walker and a flayer, and if you take this away from me, sometimes I can't speak. But I will respect the rules of engagement for this conference, and I will stay right here behind this podium, and I will engage you on their terms. It's a beautiful thing.
You can take the mic off if you want to fling a little bit.
Oh,
I'm a flinger.
oh, God bless you. All right. Yeah, this is. I feel much better already. Sarah, you rule. Thank you. All right, you've all heard municipal vulnerability preparedness, mostly MVP. People said MVP. It's Municipal Vulnerability Preparedness Program. And it's a tool that the state gave you. That's another big thing. In planning, as it's evolved over the years, we've been given tools, which is great. And we get more tools and more tools and more tools. And you've seen many of them on display this morning. I mean, the modeling is incredible. And our models can give us projections and predictions, and they usually result in plans that give us prescriptions and remedies. But there's something in between that really gets you there. And I love to talk about the human nature and the desire to experience rather than analyze. And a lot of that is what I call the gray area. They say, what have you done for the last 30 years? They say, you're not really a modeler. And you're not the typical planner. You're not about the writing the plans and shoving the plans in front of me. I said, no, I like to plan with you, not at you. And that area in between models and solid plans, I call the gray area. And now my buddy Eric, being a surfer, he'll know this. When you're out at sea, you have to get to the beach on your surfboard. And as a planner, you have to learn how to surf the gray area, because there is no map that gets you from the open water to the beach. You ride the waves, you ride the currents, you look at what's going on, right? Well, that's what the MVP program is all about. To me, they own the gray area. You'll show of hands while I'm switching slides here. Oops. Yeah, got it. Okay, down is up and up is down. That's okay, that's cool. Show of hands, how many people in their communities have been through the MVP planning process? Wow, far fewer than I thought, okay. How many people in the room are certified MVP providers and have facilitated MVP sessions? Wow, even fewer than I thought. Wow, okay. Well, the MVP program, like I said, is like nothing else that we have right now. In fact, in all the years I've been planning, I'm so excited about this because it is probably the most organic, dynamic process that we have available to us as planners and as citizens, because it incorporates not only all the knowledge that you've seen on display today, it engages you as a community, it engages people. We start out by organizing core teams in communities. It's the municipal staff, basically, and whoever else is involved. I like to involve not just the municipal staff, but also the local land trust, the Watershed Alliance, the agricultural commissions, things like that. And what do? At the core team meetings, we start out, we prepare for the workshop by organizing this core team. And in the first session of the workshops, you can either do the workshops for MVP as one long session, like an 8-hour planning day, or a couple of 4-hour sessions. My team, I am blessed with a wonderful team right here. Heidi, I haven't had a chance to work with Heidi, but people from Heidi's Shack, that's what I call it. Heidi's Shack, and various shacks, in fact, in Attleboro, up in Worcester. I've worked with them, and they are fabulous. And the thing you have to do when you prepare for this first phase, and my team, we do this, besides bringing what they bring to the table, all of the experience that they've shown you, even in the slides, it's just a fraction of what they know, the cumulative knowledge. I take all the existing plans from the community, everything that's relevant, I pass it on. So that we go in, we're prepared. We know the community, at least in its planning life, at least in what science says the community is like, what planning says the community is like, what our organizations have assessed the community to be like. So we come into these sessions and we work with the community. We ask the community to identify what they think their vulnerabilities are. And not just in one area. You'd think, okay, this is all environmental, right? No. Because resilience is based on what 3 things? Can anybody answer this question for me? What are the 3 principles that resiliency is built on? Social, economic, and environmental viability. It's a 3-legged stool. If you don't have one, you're going to fall. So, the MVP process talks about our social vulnerabilities, our environmental vulnerabilities, and our infrastructural vulnerabilities. The first session, we characterized hazards, and we talked to the communities. We asked them, where are you vulnerable? What hazards have you seen? What have you experienced? What have been the problems? And this, knowing what we have, in the can already. The next session, we come back after we identify our vulnerabilities, but we also talk about strengths too. And I'm going to tell you something about strengths. If you do something and you do something well, it's good to document it. Why? Because it sets you up for future funding. It sets you up for integration in future planning. It sets you up to work with your bylaws, all the things that Heidi was talking about before and Sarah was talking about. If you don't do things right now, or you don't recognize the things that you do in your bylaws as being compatible with what you would like to do to become more resilient, well, then you got to fix them. So you put down your strengths. This is what we did well, this is how we did it. The second session, we identify and prioritize community actions. Okay, how would we like to address the vulnerabilities that we talked about the first time? And then determine our overall priority actions. What's short-term, long-term, or ongoing? What's a high, medium, or low priority? And then we put it all together. And when we put it all together, we come up with our municipal vulnerability plan. And right now, and you've heard this, nature-based solutions, nature-based solutions, nature-based solutions. The focus of the MVP is really looking at communities to try to develop nature-based solutions, or work with nature. And my definition is a little bit different. Sarah's got the long one, the good one, the one you should remember. Mine is basically using natural systems, or systems that mimic. Like the Crane Street that Sarah just showed you, the enhanced wetland, that worked. Why? Because it works like nature would work if it were still in an area. It had been blown out, we recovered it. And work in tandem with traditional approaches to address natural hazards like flooding, erosion, drought, and heat islands. One of the other things I like to emphasize is, if you're going to work with nature, especially if you're going to put in add-on structures, like gray infrastructure, look at the resiliency built into nature and work with that. Don't try to make nature better without respecting what's already there on the ground. And this is examples of green infrastructure. This is a slide that actually Sarah had. And this is another one. This is an example of low impact development. The infiltration off a street where we can direct drainage, street drainage. And nature-based solutions, you just say, a lot of times when you go into a community, especially where it's more urbanized, they say, well, nature-based solutions, it sounds like it's something that's really out there for a rural community. This is something, if you're out in the country, if you have a lot of open space, if there's a lot of water, this, that, that sounds like it's a perfect fit, but how can it fit for me? Well, if you have open space, look at preserving it for actual municipal benefits. MS4 areas, if you have open space and you have to do stormwater treatment, you can look at the open space areas maybe to help you handle drainage, infiltrate water, rainwater, precipitation. But there's always open space you can use. And the really valuable tool in communicating this is the green infrastructure maps that Manomet developed. And a lot of times when we sit down at a table, we put maps on the table with people, as well as newsprint, because it's their move, they think. They look at the green infrastructure maps, and that really turns the light on as far as what we have, what we should be protecting, how we should integrate what we have. And we can also integrate concepts into new development. You heard about that. Sarah and Heidi both mentioned that. You can do things like roadside gardens, rain gardens, swales, country drainage, all those kind of things. And you can do it at a neighborhood scale. When it gets down to saying, what can we do as people, local neighborhoods, neighborhood associations even, or what can we ask developers to do when they come in and develop these new neighborhoods? This is what you do. And this is where we're going to circle back to the bylaws. If your bylaws don't allow you to be creative, then these things are a dream. So you correct it. My voice is going a little bit because I have allergies, I'm sorry. And this is one of Heidi's shacks, actually. This is in Worcester. And if you look at everything in front there, that's a beautiful rain garden. And I believe all your parking lot drainage and all the stormwater on site is actually filtered into that. And that's a real good local example. And that's in Worcester. So one of the things we really emphasize when we go through the planning process with communities is what services are provided by nature. You talk about nature-based solutions. Well, what do we get from nature? Well, nature-based services and solutions, we could control flooding, non-point source water pollution, you've heard that. Maximize groundwater recharge, everybody's mentioned that. Limit flooding associated with sea level rise in coastal areas, yeah, that works too. Oh, relief is here, all right. I did not produce this.
It increases the volume of water in the room.
It does. The water vapor is now coming out of me. We're recharging. Thank you very much. Eliminate flooding associated with sea level rise. And Eric mentioned that. Sarah mentioned that. And these are things in our coastal communities. One of the things I really mention in coastal communities too is how many communities in here, or do you know if you have tidal rivers? Tidal rivers. All right. Well, guess what? You're on a coastline. And one of the things that happens with tidal rivers, and I've said this to all my MVP communities because they say, sea level rise, yeah, that'd be like down on the south coast, you know, like in Fall River and Westport and Dartmouth or over here, you know, Kingston or Plymouth. No, if you're on a coastal river and it's flowing inland, it's tidally influenced, I said, you get the best of both worlds. I said, you get it coming and going, because I said, the coast gets hit, hammered, everything recedes. You get hit, hammered by the tide and the tidal surge, it sits there because you're in low-lying areas. It'll sit there for days, and the rivers crest for days. So the flood impacts and the erosion impacts and every other impact is multiplied. So these are things you really have to think about in your planning where you are. It also supports free service provided by nature, and nature-based solutions supports biodiversity. That's plants and animals. That's wildlife corridors. Controls tax rates and reduces infrastructure costs. Why? Because if you have to apply less municipal services to solve the problems and let nature do it, you're going to save tax money. Less development, the whole bit. And it enhances the quality of life. Because if we preserve our open space, I mean, to me, that slide, that's in Marion. We went down there and did the MVP with them. That's quality of life. But we're preserving the coastline, preserving the marsh. This is one of the big strategies because they are extremely susceptible to flood. And these are the hazards, and you saw these in some slides too. We identify hazards with the folks, that riverine flooding, coastal flooding, coastal erosion, stormwater flooding, and the heat effects in islands. What can nature-based solutions do? Well, you can conserve the green infrastructure. Integrate as far as low impact development and green infrastructure. And those are slides that Heidi's talk and Sarah's talk covered. And you can restore. Those are the things like Crane Street and some of the things that we've done in other places. We have examples on the ground where you've integrated low impact development or green infrastructure solutions to help mimic what nature does. You bring it back and restore. And what does it do? Well, you avoid additional costs, you enhance safety, and you prop up those environmental services that are already out there. And this is my favorite slide. What's the high-tech driver of the MVP program? You've heard about a whole lot of high-tech drivers today, a whole lot of programs. This is mine. It's called Vox Humana 2.0. Vox Humana is Latin for human voice. Why? Because it depends on people. The MVP program is people-driven. It's people like you in a room planning with people like us. As facilitators, our job is to really engage you on the community level. And so far, the work that we've done, the diversity of experience, age experience, youthful enthusiasm, like I said, municipal employees, we bring people in from the outside who have interest, the land trusts, the watershed alliances. This is where the rubber meets the road. We ask you to define, again, going back to that beginning slide, what are the forces of nature, climate change, whatever, flood, drought cycles, extreme weather, extreme temperatures. What are the big factors that affect everything in your community? What are the stressors that are prevalent in your community? What are the vulnerabilities in your community? What are the strengths? And when we reach this point, we step back, we facilitate, and we say, you tell us, how does it work? How does it work for you? What would you like to see done? And if you look at that slide, those are one of Manomet's maps on the tables. The matrix up in the back is where we record all the information. And the screen up in front is where we made our choices. Very diplomatic. It's voted on by the people who are affected. And these are examples of things that I pulled out of the strategies we've come up with. These are examples of MVP planning strategies that have actually come out of the sessions. And I had hundreds of them, but I thought these would be most appropriate to the water conference. Identifying and protecting vulnerable areas containing critical green infrastructure. That goes back to the maps. Why? Because if our forests are working, we have the ground cover that we need, we have the understory that we need, we protect our rivers and streams that run by these things, we protect our open space, we protect our marshland along the coast. This is going to help us become more resilient, or retain our resiliency, retain our integrity. The other thing that's come up a lot is forest assessment and forest planning. Show of hands, how many people, when they consider planning for water and water management, think forest first and foremost? About half, yeah. And a lot of people, when you go around the table, they'll say what we need really is a forestry management plan. If you're talking about vulnerability, a lot of it has to do with utilities and blowdown recently, The wires come down, you lose power, so people say that's the big threat. Other people have said, yeah, but when we lose the forests, we lose the forest cover, the understory, we have bare soils, our water system isn't working the way it should. We don't absorb, we don't conduct, convey, and if we have bare soil, we're losing that valuable resource right there too, and we're probably releasing more carbon into the atmosphere in the long term. So one of the things that's come out of this is really a comprehensive approach where towns, the last 3 towns we've worked with, have said what we should do is put together a comprehensive forestry management plan that brings in independent foresters to assess the forest in and around our roadways, our vulnerable roadways, but townwide for disease, because that's become a big factor also. Vulnerability of our utilities, and in areas especially around our wells, where we have to retain the recharge and recharge capacity. So they're talking about integrated planning and working with people you don't normally work with or would invite to the table to do an integrated municipal plan, which I thought was great. Dam removal and river restoration. I see my buddy Wicked Beth Lambert back there. And this has come up, and I think because of some of the work that we've done in the Taunton River Basin, on the Mill River, Rattlesnake Brook, and the Cotley River, people see that dam removal and streamside restoration rehabilitation is effective. It improves water quality, improves the movement of water, and contrary to popular belief, most people think that when you remove a dam, the water will go away. In fact, in the process of removing dams on the Mill River, Beth and I both experienced people who said, the river will turn into a drainage ditch if you remove the dam. What happens is we tell them, we're actually going to reclaim floodplain. Now, I thought of this when we were talking about infiltration, too much infiltration. Well, you have to play around. You have to know where you can afford to infiltrate, where you should infiltrate, where you should improve the condition of your rivers, and how you can improve the condition of your rivers. On the Wittenden Dam on the Mill River, we actually built floodplain. We reclaimed floodplain from what was in the impoundment. Same thing as State Hospital Dam. So people who were on the border of the impoundment and used to get flooded out regularly, sometimes maybe in 2-inch rainstorms, after we did the dam removals, reclaimed the floodplain, replanted with native vegetation, we had a 4.5-inch rain in July. And a guy who used to get flooded out regularly, who is now probably about 100 yards from the river, I ran into him on a bridge at Wittenden, and I said, hey, how'd you do in the last storm? He flooded up the back door again. He goes, what are you, nuts? He goes, I must be a mile from the river, just looking out. I said, so where'd the water go? He goes, well, it kind of came up and went into the grass. I said, oh, the floodplain? He goes, yeah. And I said, that's what we're going to do the whole time. This was the same guy who said it would turn into a drainage ditch. So it worked. But you know what he did? He went, oh, that's what you were talking about. I said, yeah. Stream crossing upgrades. And these are our culverts, short span bridges, anything that will affect or obstruct flow, resident species, water quality, the whole bit. One of the really interesting things about the stream crossing upgrades and the next one, the culvert replacements, is you can look at the climate of the statewide database there. Yeah, the network. And, yeah, NARRAGA, yeah. And you can see if your culvert's in the 5 to 15% category as far as really needing to be replaced. And a lot of the towns and a lot of the people that I've worked with, a lot of the culverts that have come up during the MVP discussions are not necessarily in that category. But does it mean they're any less important? No, and this is where the native knowledge, actually the institutional knowledge around the table can come up. I've been in rooms where the culverts are probably more than 100 years old. They're not on the priority list, but they're what they call farmers' culverts. They're made out of mortar and fieldstone. And every time you get a flood, that mortar, the integrity of that gets compromised. There's no signs on these bridges yet or over these culverts that say there's a weight limit. But they know these things are in a state of collapse. They don't function well. Should they be replaced? Yeah. But do I know it by looking at the data we have? No. I have to depend on the local people, local knowledge. And they know where all the streams go and how this will impact everything north and south of it, east and west of it. And a lot of times it's your first responders who bring these things to light, which again, it's the people you get together in the room with that core team. I've had fire chiefs and police chiefs tell DPW supers where they should be looking at culverts and where floods occur in town. Because they say, if I can't go down this road, if I have to go around, that 10, 15, 20 minutes could mean the difference between life and death for somebody. And that's a vulnerability. Cold water streams and ORW certification. Well, everybody knows about outstanding resource waters because we have for drinking water, right? Well, in 2014, cold water streams were also certified as ORWs. And someone was mentioning cold water streams in the USGS about how they find and classify the cold water streams. Well, that's another tool you have now, because they're subject to DEP stormwater standards as far as treatment and what you can do. The other one was stormwater retrofits, low impact development. We talked about that. Comprehensive bylaw review. Well, that's the thing. If you want to be creative, if you want to promote resilience, if you want to have the capacity to do so, and your bylaws don't allow you to, you're going to have to settle for the standard. So the deep bylaw dive that Heidi was talking about, Sarah was talking about, it's well worth it. And the other one, assessing areas for road safety, water quality improvement, habitat restoration, and land conversion. And in land conversion, I was thinking of Alex Hackman, who's going to be here for lunch, so we'll set the table for you here, Alex. One of the last MVP sessions I went to, one of the guys around the table was one of the old timers. And we were talking about some of the programs that are out there now. Oh, we have this, we have that. We're talking about Cranberry Bog retirement programs a little bit. And he just looked around the table at everybody, and this was great. He said, you know, have any of you guys ever thought about the unanticipated consequences of bog abandonment? Everybody goes, what? And they said, yeah. He goes, you know, a bunch of us, we're in our 80s now. He goes, we're not going to farm these things. We got no one who wants to farm cranberries. He goes, so we're not going to retire them. We'll just walk away from them. And he goes, then what happens? Are we going to get a slug of pollutant being drained out of these things because the stream runs by them for the next few years till all the nitrogen and everything else we put on them is gone? Or are they going to turn into rock-hard pieces of ground that support a pine forest? And everybody just went, wow, that's brilliant. But you know what? It's the brilliance that comes up in these MVP sessions. It's the people around the table who know their towns better than us. Like I said, we can come in very, very prepared, but we can't say we know your town and what you should be doing better than you do. And what can we do for potential funding? Well, that's the other thing. I ran into a guy who was a selectman, and great, he was, again, one of these brilliant thinkers, and he goes, I've been planning for 15 years. I have plans on my shelf stacked this high. How much of it have we done? This much. Why? Because we put all this effort into it. We throw all this planning time into it. And he goes, honestly, he told me, he goes, that planning with you and not at you, he goes, we've been planned at. Everybody has an idea of what we should be doing. He goes, so we have to figure out which idea is best. But then I don't have the resources to do it. I can't go to town meeting and get the money. My boards don't have the budgets. He said, what's different about the MVP? I said, the MVP is a plan that you put together. We do it quickly, you get certified, you're eligible for state money. It's your words, it's your action, everything is memorialized, it's your plan. So I said, the MVP grants are out there. And I said, and for the fact that everything is memorialized, you can go after these other grants because it sets you up in these grant platforms. So Complete Streets, how many communities have used Complete Streets or Complete Streets priority plan? Oh, look at the Complete Streets program, especially with your drainage and your stormwater management. And Chapter 90 funds. You can couple local Chapter 90 funds with Complete Streets money. The DER culvert grant replacement and priority projects and assistance. I saw a lot of communities, go in with the culvert replacements this year. How about priority projects? Anybody do priority projects? Okay. There's a ton of EEA planning grants. There's district local technical assistance for the RPAs. Anybody do DLTA in the community? Check it out with your RPA. The Seawall Grant Program, DCS has a number of lands programs. We've probably all been through that with open space. MDOT, Agriculture's program. Mass Environmental Trust for years, people have been using that. You've heard about 604B and 319 grant programs today. We use one very successfully in Norton. The NRCS has programs. NOAA has multiple programs, especially dam removal, EPA. The National Estuaries programs. And for towns that are classified as rural development programs, there's a ton of programs available. For populations below 10,000, public-private partnerships, foundations and grants, MCZM for you coastal people, coastal pollution remediation, which is the grants coming out soon, and coastal resiliency grants. And do we really have help? Well, yeah. Through the MVP program last year, there was $5 million available in assistance and action grants once you went through the MVP planning process and got certified. This year, there's going to be $10 million available. And if you act with your neighbors, It's really incentivized too, because the cap on local projects is $2 million. The cap on regional projects is $5 million. And pulling right out of the governor's text, projects that propose nature-based solutions or strategies that rely on green infrastructure or conservation and enhancement of natural systems to improve community resilience will receive higher scores. So if you go through the MVP planning process, it bumps you up a couple of rungs on the funding ladder. So please, if you haven't done this stuff, look into it, investigate it. Thank you.
All right, so just a couple really quick announcements before lunch. Some people have asked about the availability of the slides. They will be available as PDFs after the conference. The presentations are also being filmed by Hanson Community Television, so there'll be a link to that. You can rewatch the whole thing at your leisure.